Okay, so for the first thing, it's telling me to write in standard form. What you need to remember is that it wants you to simplify this. We did this on day 1, on 6-1. I want you to simplify this first and to write it as an expression. So you need to remember what this terminology means. Expression is different than a function. What's the difference between an expression and a function? Or they used to call it an equation, but now they're calling it a function more often. If I look at one like example 3 right here, what's the difference between this being a function and this being just an expression? What's this one not going to have when you're done with it that this one does? An equal. It's not going to have an f of x equal. It's not going to have a y equal. So that's what you got to know the difference. If it says expression, there's not going to be an equal sign in when I'm done. I'm just going to go FOIL this out like we did on day 1. And we're going to take this and we're going to say this is x squared. Outermost is going to be plus 3x. Innermost is going to give me negative x. And outermost is going to give me minus 3. Then I'm going to combine these two in the middle. And then I'm going to multiply it by x plus 4. So then I'll distribute over the top. I'll distribute it to the bottom just like we did on day 1. X cubed plus 2x squared minus 3x. And then I'm going to do 4 on the bottom. 4x squared plus 8x, and then I got a minus 12. Then I start going through and I look for like terms. So this is nothing new. This is what we were doing when we did last Monday, Tuesday. I got x cubed plus 6x squared. That gives me plus 5x minus 12. All right. So I end up with a cubic, because it's 3rd degree, 4-term polynomial, right? So that was just day 1 stuff. Do the same thing on B. Go ahead and do that one real quick. So I get the same thing. I get a cubic 4-term polynomial. Alright, so all look familiar? Alright, so this is called writing a polynomial in standard form. We're always going to simplify it. We're going to write it out in order from greatest to least in degree. Alright, this down here is doing the exact opposite. So I'm going to make a little note that example 1, example 2 are called inverse operations, because inverse means opposite. Inverse operations. How I do example 1 is the exact opposite of what my goal is on example 2. So if I want to take this and write it in factored form instead, then I got to go look at the problem and say, what's the first rule of factoring? What do I always take out first? What's the first rule of factoring? Take out the GCF, right. So I'm going to take the GCF out of this, which is a 3x. Get a x squared there. 18 divided by 3 is minus 6x. 24 divided by 3 is plus 8. And then if I look at 8, 4 and 2 also add to 6, so that's how I finish factoring it. So I got 3x, x minus 4, x minus 2. Alright, so we went from here, we multiplied to get from there to there, and we went the exact opposite here. We factored to get from a standard form down to a factor. Alright? So again, this is chapter 6 I told you the other day. It's piecing everything together, chapters 1 through 3, and then chapter 5. Chapter 4 was matrices, so that's why it's not part of this stuff. Alright, try the same thing on B. Take out the GCF, then factor it. Okay, so I know I'm using either a 4 and a 3 to get 12, a 6 and a 2 to get 12. Probably not a 12 and a 1, but I'll write it down. Then I'm looking at that 2 right there. So this is where I'm guessing checking. So that's why I'm switching to a pencil in case I guess and check wrong. I like 2 times 4 is 8 because it's really close to 5 already. So I'm going to put the 4 right here. If I put the 4 there, that means I got to put the 3 in the other spot. I want the 8 to be negative. I want the 3 to be positive. Alright, I know that's right, but I'm going to show you again, remind you how you double checked it. You just FOIL it like we were doing up here. So I get 2x squared. Outermost gives me negative 8x. Innermost gives me plus 3x. There it is. What do those two add up to? What's negative 8x plus 3x? There it is right there. So it worked. Alright, so I know a lot of you can do this in your head. Do it on the side, whatever. I'm going to erase it because I would have done that in my head. Just check and see if the middles were equal. So this is completely factored. Alright, so again, chapter 5 stuff. But we need to know how to do all this to do the chapter 6 stuff. Let's go down to example 6 again and let's apply some of this. We're going to start talking about graphs. The first thing I want you to remember, there was like about a 3-week stretch I had over on the sideboard, all this written down, that I told you that a 0 was the same thing as a solution. I also told you a 0 was the same thing as an x-intercept. You remember what I'm talking about? How that was written on the board for like 3 weeks? Jordan, you remember that? Alright, so that's important to remember all this. A 0 is the same thing as a solution. But the reason why is because if I went over here and I replaced that y with a 0, then I can tell what all these solutions are. Like right now, what would I plug in place of x to make this a 0? Right here on this part 1 right here, x minus 2. What could I plug in place of x to make it a 0? 2. So one of the solutions is x minus 2 equals 0, and I get a 2. What would be the solution for this one? Negative 1. So I'm calling them solutions, but right now they are the same thing as zeros, so they're calling them zeros. What's the last one? Negative 3. Okay. These mean the same thing as x-intercepts, so whenever we put these in our calculator in a second, you're going to see that this is where they cross the x-axis. So get your calculator out, and we're going to do this stuff right here. Hit y equals, we're going to clear everything out. Alright, so I get my calculator out. First thing, last week we were working on stat plots, which we do not want anymore. That's why it's telling you to turn off the plot 1. So I hit second stat plot and turn this off, because you're probably all going to have them turned on because you're just using it turned on. So once you turn that off, we're going to go into y equals. And it tells me to type the equations in just as you see it above. So that would be x minus 2. So I'm going to switch this to a 2. I need a plus 1. And then I need a x plus 3, right? Yeah. So change it to a plus. So now that I've got that in, if I hit zoom 6, I want you to read what the word says up. Zoom 6 means to standardize. Yours is probably not standardized already. Mine is, just because I did this last block. But that's just changing that back to negative 10, positive 10, negative 10, positive 10. So when I hit zoom 6, it'll draw my new graph. Alright, there it is. What's x right there on your picture? Look where I'm pointing at. What's x right there? Come on. Where is that? What is x's value right there? It's already on the sheet. It's negative 3. What's x's value right here? Negative 1, because these are all the x-intercepts. Zeros mean the same thing as x-intercepts. So what's this x value right here? 2. Alright, so really pay attention to how this is all related so it becomes easier and easier for you. So these are where all the 3 spots where they cross the x-axis are my 3 solutions. Alright, or they're calling zeros. Alright, so they all mean the same thing. So let me see where I'm at now on the calculator. In second table, you can use arrow up and down to see the zeros. So if I want to look and see where the zeros are, this is what this is telling me right here. I hit second, right above graph it says table, and I can look at this and say, when y is 0, x is negative 3. There's one of them. When y is 0, x is negative 1. There's another 0. And there's the other one. When y is 0, x is 2. Okay? Now the other thing we want to be able to do is find a min and max. What word did we say was synonymous with a maximum? I can't see because this thing's in the way. Move it up a little. What is synonymous with the word maximum and minimum? Very good. Vertex. Write that right above them again, just so you remember. Okay, so because now if I look at the picture of this thing, if I go back to my graph, there's a vertex, there's a vertex. This is a mountaintop, so it's a max. This is a valley, so it's a min. Okay? So let's go do this max right here. So second, it says to second calculate max. So second calculate number 4. I am definitely not left of the mountaintop, so I got to go left. Alright, now I'm left of the mountaintop. I hit enter. Now I got to go right of the mountaintop. Enter again, enter again. There is my maximum right there. So my maximum on this problem, I'm going to go right here and write down negative 2.1, comma, 4.1. And then next we got to go find the valley. So go say where the minimum is. Do the same thing. Second, calculate minimum. So you want to do that real quick. Left of the valley, right of the valley. And now it's flashing on the valley. 0.8, comma, negative 8.2. All right, any questions with that so far? It's pretty easy, right? Do the exact same thing then on B. So I got a min of 6.2, comma, negative 3.1. Got a max at 3.8, comma 3.1. Does that sound right? Don't everybody tell me at once. Did you guys get that? All right, flip it over. So we got mins, maxes, we got zeros. Now we're gonna just talk about how we're doing the exact same thing but going backwards with this. So in other words, right here where it tells me I'm given a 0, 2, negative 3, 0. Don't make this harder than it is. You told me what this is pretty easily. So I'm just going to go backwards and do the opposite and write a factor instead. All right? So I'm going from this to this instead on the back side. So then, what is that thing's factor going to be? That 2 right there. x minus 2. Right? So I'm going to put x minus 2. What's that thing's factor going to be? X plus 3. And then what do you think that thing's factor is? Just x. X plus 0, x minus 0, so just x. And then it says to write in standard form. On the front, remember it told me to write in standard form? Did I leave it like this? Yes, no? Did I leave it like that? You need to go back and look at the front. Look at the front. What did we do instead, Kaylee? What? Yeah, you multiplied it out. I just didn't hear you. Yeah, you're going to multiply that out. FOIL these two out. I think that's the easiest order to do it in. FOIL those two, and then just distribute an x at the end. So do that real quick. FOIL that out, then distribute the x at the end. So you see how doing a lot of this stuff is the same thing, it's just worded differently. So you just got to pay attention to the wording as you're working through these problems. All right, so do the same thing on B. Figure out the factors, and then just multiply it out. Look good? X cubed plus 5x squared plus 2x minus 8. Okay, so then on the last part, almost there, a linear factor of a polynomial is repeated, then the zero is repeated. A repeated zero is called a multiple zero. A multiple zero has a multiplicity equal to the number of times the zero occurs. All right, this idea is really easy. You're just doing it. What we do need to do though is factor first. So take this thing and factor it down for me. Take out its GCF and factor it down. Okay, I will tell you there are 3 zeros. What's one of the zeros? -2. Yep, that one right there has a 0 of -2. What's another one? -4. And then, what's the last one? Zero. Yeah, it doesn't matter if this is cubed, fourth power, whatever it is, it's still 0. So there's nothing plus or minus to it. Alright, here's all multiplicity is. Multiplicity, it just wants to know what degree each factor is. So, if I look at -2, and I look at the little power next to it, what degree is that? 1. So this is, -2 just has a multiplicity of 1. -4 also has a multiplicity of what? 1. 0, though, has a multiplicity of what? Second degree means, so all you need to do whenever you do these is look at the degree. Of the factor. Look at the degree of the factor. Okay? So then, like if I do this one's already factored, so it's pretty easy to do. What's one of my zeros? X equals what? 2. What's the other one? Alright, they try to trick you, but there's really only 2 of them, right? Because they got x plus 1 twice. What's the multiplicity of the x equals 2 factor? 1. What's the multiplicity of the x equals -1 factor? 2 plus 1. There's 3 of them actually. This has 2 of them, but that has 1 of them. So this thing has a multiplicity of 3. Alright, back to the last one and then figure out what its zeros are and multiplicity are. Multiplicity of 0. How many times is 0 happening? 1. Multiplicity of 2. 2. So that's all there is. That's all there is to multiplicity. Is look at the degree of whatever that solution has. All right, so that is it. Let me stop my recording.